All right, let's continue from last time. This will be hopefully pretty quick, or well, we'll see. So yeah, last time I was just like kind of doing the roadmap, right? So like we kind of have our net, and then what we need now in the net, basically, we not only do we have game state discretization on the input, but we're also gonna have for the like the policy, we're gonna have the discretization of like these 8 directions, as opposed to infinite possibilities. We're just gonna assume that there's only 8 cardinal directions to use for each coin. So that's a branching factor of 24, because each player has 3 coins, and each 3 coins times 8 directions per coin is 24. So yeah, so like we have to build a policy, right? So like I already talked about the output, so then we have to kind of extract it into a policy. So one thing I think that, in fact, I just want to like kind of like test it out first. I want to like, or actually, let me think. So like, how do we get the policy, right? Like, one thing I was thinking of doing, which I mentioned earlier, is like, you know how like the move for connect 4 has like a column index? I was thinking of kind of creating a move index, and this is actually for the purpose of like, you know how like everything is like left to right, like we're doing like a training and back, like we're doing like the self play, like left to right, like constructively, like kind of building up, like taking the net and like kind of getting all the information we need to play game with ourselves for self play, and then the reverse direction, which is training. Like for that, like I think this notion of move index would be helpful, but like, so anyways, we have 8 move directions. It's a bit of a smudge on the screen. Let me just clean that. Okay, well, let's just first make sure I'm recording stuff to begin with. So terminal, wiggle it around, cd BumperCoins bot, get status. Yep, I pushed it. Get log. Last time we were tentative crate model. That's yes. So again, like this model is a really kind of a heavy model. I mean, pretty large compared to Connect 4. Like if you look at the model, like the weights.bin, right? Like that's it's quite large, right? Like 51 megs. Anyways, it's a pretty big file. Like compare that to like Connect 4 model weights.bin. Oh, actually no. Okay, so it's 5 times larger than the Connect 4 one. Oh, okay, not bad, not bad. Okay, so anyways, well, I know the never mind. So anyways, what we were talking about, yeah, we're talking about just, let me see net.ts, and then the other one for Connect 4, to see now that we have crate model. Well, so here's the Connect 4 one. We have crate model, and then, so that creates the neural net. And that is, we have it indeed, we have it, and we created it and we commented it out, so it's consistent. Next thing is convert game state to model input. Yep, we have that right here. We have convert game state to model input, and that's it. That's all we have. We have, so like, we have this. And then now what we need is well, this is a helper method, right? For training, we need get policy and value. So that's like the new thing which we have to create, like the next step, right? And that is basically like this circle is for net, which we just did, and then we need to kind of like do these circles, like from the net's output, how do we interpret the output and extract the policy from it, right? So that's like get policy and value, like actually like parse the output of the neural net, right? So we copy that line. Wait, what? All right, this is the one. I see. Discretize coordinates is a helper function. It'll be at the end. And what we need is get policy and value, right? We do even have a notion of policy? No, we don't. Okay, so then CP BumperCoins. No, not BumperCoins, Connect 4. policy.ts, and then let's just copy that. Status ls. Okay, so we now have policy. Let's just look at policy. So moves and probabilities is to, we have a notion of a move already, a number, a constructor, clone. What does clone do again? Oh, we need clone for symmetries, right? So then copy moves and probabilities. For move, copy. Oh, I see. So we need this notion of a move.clone. And we need to add a clone on move. And we need to and move and prob one. Yeah, just copies the weight. Okay. It's a primitive. We can do that. Okay, fair enough. Okay, so the main thing we have to do, because right now if you try to compile this, it's not going to work because there's no clone method, right? Exactly. The property clone does not exist on type move. So let's fix that. Move.ts, and let's just go to connect for's moves. Connect for move.ts. And one thing which I want to do actually is like, just so we have a coin ID, there's another thing which I want to do, which is a notion of a move ID, which is a bit redundant, but what I want, or sorry, number, is like, you know how like we have like these directions, like I want to like call this direction 0, 1, 2, 3, 4, 5, 6, and 7. So now given a coin ID, like we only need like these two things. The coin, like the let's call that the coin ID, CID, and then the direction, like the direction ID did. Like we just need like these two, the coin and the dir, and that specifies it completely. But then for the sake of the physics engine, we're gonna like have the VX and the VY, the VX and the VY also there, even though like the move ID kind of gives you all the information. Because while we don't need it right now, like from left to right in this map, right? We don't need it right now because like from the thing, we can like look at the planes and like kind of like compute it. But like if you kind of like look at the policy, like given a move and like some velocity, like let's say you have a move which is like coin 1, like see like here's your like move. You have like one move, like you have like a move 1 with like 50% and like move 2 with like 50% and everything else with like 0%. So like this one like says, hey, like move this coin, like move this C1, like move it like pi over 2 comma pi over 2, or wait, what am I saying? No. This is not polar coordinates. This is a like move it like whatever, like point, like whatever the number, like some number here, like VX and VY, right? Like, the point, wait, what am I talking about? Yeah, so I'm saying that like the reason why we would like need this is like if we have like a bunch of moves, right? Like if you have some like policy, some policy.ts, like we have a policy object which has some moves and some weights, where a move is like in this format or whatever, like it just specifies a move completely, like the format we have, whatever. We just have a coin, we just have a policy, right? Okay, so let's take it from the top. We have a policy, right? But then when we're actually training it into a network, like how are we reversing this? Like you see how we're extracting it? Like from the vector output of the policy head from the neural network, we're extracting a policy. And that's what this function, which we're about to do, called getMoveInValue net.ts would do, right? But then when we're reversing that, how do we do that, right? Like given the moves, how do we compute the policy, right? So like these directions are kind of like the same notion of an offset, right? Like I talked about this in a previous thing, like the policy output is a vector, right? And its vector is basically like 8 image stacks, right? It's like 8 image stacks for like the number 8 is like the number of move directions. And then a given index stack, like to like kind of start at the top left corner, like let's just say that this is the plane, this is like the third plane, right? Like let's say this is not a dot, like 1, 2, 3, right? It's like 0, 1, and 2. So this is like the third one. So then like the top left corner cell is basically like 2 times 15 times 20, where 15 times 20 is like the area of like each thing. So like you're kind of like offsetting like that whole strategy, which we've done several times by now, right? So basically for like the coins, like the policy, we have to like kind of like use the same helper function, like which whatever, like it's called like, which like kind of converts from the, like extracts the discretized coordinates from the coin. And the point is like we need to know like the index, like which plane it's in. Again, this is a flat vector, but we're just like visualizing as a plane. So it's like the actual move, and again, I've talked about this in a pretty early video, is like kind of like divided into like 1, 2, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7. Like, so basically, like the first whatever, like the first 15 times 20, the first 300 values are like this is the first 300 values kind of corresponds to this. Second 300 values corresponds to second, and so forth, dot until the end, where each of them kind of like, so like this would be like 0 degrees, like move index 0, move index 1, move index 7. And then like in each entry here inside this is like the same kind of going this way and like this way and like sweeping like row by row, like kind of skipping the rows and then the column offset, like notions of offsets and like mixed radix numbers, whatever, like some very basic stuff. But the point is like we need to kind of like figure out this direction. And that's why I think it's convenient to just kind of just stamp the direction on it too. That's the whole point. So the whole point is like clone, basically I'm introducing this concept a bit earlier, even though we need it for training, because I just want to be nice and proper and like have clone do it too, you know? So now when we're doing clone, so then we need to pass in the move ID too. Just like that. Okay, so then this move ID is move ID. Okay, perfect. So now when we're cloning it, we need to do this dot coin ID, this dot move ID, fixed point dot clone, and fixed point dot clone, right? Because again, we have to kind of clone the object too. Bx. Sorry about that. Okay, so to clone a move, we take the move, so then the constructor takes in the coin ID, which is just that, the move ID, which is just that, the clone of the VX, like copy the X velocity, then copy the Y velocity component, and that's it. And that's clone. Okay, so now we have clone. That's good. So now let's run the TSC command again, see if policy compiles. Ah yes, this.vx. Okay, thanks TypeScript for the quick assist. Just like that. Oops. I'm stupid. All right, let's yes. Just like that. Clone the, yeah, okay. Perfect. Status. Let's just do a quick git diff. Okay. Status, clear, git status. Okay, so now it's time to actually do some work, right? Perfect. So now it's time to work on this function. Get policy and value. So let's see how it's done there. Get policy and value, right? This is from Connect 4. So let's kind of copy these things right here. Actually, let's just copy the whole function. Why not? Actually, no, let's not. Let's start off by copying this one paragraph or this one block, whatever you want to call it. And put it in comments just to note that it's copied. Okay, so we have an input, which is convert game state to model input, and that's the same function as signature. Yeah, we're just using it right there. Okay, so that's good. We can use that line. Prediction. Okay, model.predict. That's just TensorFlow. Oh, okay. Well, it looks like we can use all these blocks. Good. Now here is GameState.getLegalMoves, right? And I talked about this in one of like the earlier like kind of like when we finished Connect 4 and started BumperCoins work. Like I talked about how like when I was working on the GameState objects, various functions, I mentioned I did a grep on getLegalMoves and I saw that it was only used once in net.ts. So yeah, so like here's where logic will differ, but at the end, ultimately, like let's just kind of copy this, the endpoint. Okay. So now, what we need to do is we need to filter it out, right? So get policy and value. Okay, so filter out illegal moves and renormalize. Okay, so now let's look at the game state, right? Let us look at the game state and then look at the coins for the player to move, right? You can copy it from here. I'm going to copy this line. Actually, no, we can use that filter technique, right? Let me just refresh my knowledge of game state. Get coins for a player. Yeah, this one, right? Get coins for a player and then player 1 or not, right? Wrong file. Game state dot get coins for player. And what is the player? Is P1, right? So that is game state dot is P1 turn. Game state dot is P1 turn, right? So let's say that it is P1 turn, right? So let's say player 1 turn is true. So if player 1 turn is true, that means it's player 1 who currently has to move, right? So that means player 1's coins should be considered, because a policy only applies to player 1's coins, not player 2's coins. You cannot move your opponent's coin, like pieces in your turn, obviously. So get coins for a player. And what does get coins for a player do again? The implementation? It filters the coin, whether this coin.p1 is P1, and then we're passing P1 is true because it's player 1's turn. So like this one is true. So the coin.player1 matches like is true. So then the coin is player 1, then that's correct, and we get all the coins for player 1. Now if it's false, then we get the coins for player 2. And it will be false if and only if game state.player1 turn is false, which means that it's player 2's turn. So if player 2's turn, we get player 2's coin, player 1's turn, we get player 1's coin. So this looks like it is correct. So we have the correct coins at least, right? That's good. We have the correct coins. That is very nice. Take some water. Okay. Okay, now for each coin that exists, we need to kind of iterate over the move directions, right? Let num move ders. So this is a nested one. Let's put some space here. For let move. What did I call that index name? Direction ID. Okay, move direction ID or dir ID. Direction index equals 0. Index is less than num move ders. Okay, from 0 to 7. Okay. So now let's just have a to-do function. Actually, no, let's put it in the move. Actually, never mind. Yeah, never mind. another helper method function, get move velocity, get move velocity from movedir, and that is a int or a move dir. Actually, let's instead of dir index, let's call it move dir. Number, and this will return 2 fixed points, right? To do return do the trig and remember to do 0.4 times the max velocity. Returns a velocity vector at the angle specified by movedir and magnitude of 0.4 times max velocity, which I talked about earlier. To do, implement this, do the trig. For now, let's return a stub. Return fixed point dot 0, and same thing there, just a dummy value just to get it to compile. Let's add some space. Just space to like let me know that I should do it. Right, okay, so now for each move there, what we want to do is we want to, WN, get legal moves with probs is the actual thing, right? So legal moves with probs, and then after we do this, then we have to do the normalization to get it to normalize, so they all add up to 1. Okay, so then what do we do, right? What do we do? So for each coin, we have these directions. Then we want to, let move equals to a new move of the coin.id move direction, then the move direction, and the let's call it a VX, VY, where we're let move velocity just copy this whole line for now. Okay, so just like that. So now move velocity. Zero. And 1. Turns in form bx, by. Just like that, right? Fairly standard. So now we have the move. Now what is the probability, right? We have to use our policy data and get it. So how do we do that? Like, what's the index, right? Let's policy data index number equal to question mark. And once we solve that, like say at the end, then let's wait, well, what do we do in the file? Like, how do we populate it? Dot push move prob. Oh, and some prob too. Okay, yeah, let's just copy this. Policy data of the policy data index. Push move prob. Okay, good. So now all we have to do is compute the policy data index, right? So how do we do that? Well, we have the okay, so it's to like discretize the coin again, right? Get discretized coordinates. Row and column. Okay. Okay. I have to be careful about that. Wait, we can extract this. We should extract that. Because there's no need to do it for every move. Coordinates, that's the discretized coordinates of inform row index, column index. So then what? So let's see, we have the move at movedir times the game state dot whatever, like num rows, num columns. It's like num move dirs. For each given dir, it's the number of rows times number of columns. That so this basically gives us the offset, like this basically kind of like specifies like see these left points which I'm kind of blurring, like it specifies like which bracket, like if we're in like 0, 1 to 7, if we're in like 2, if we're in the third one, the move direction 0, 1, 2, if we're kind of like in pi over 2, if we're going 90 degrees, if we're going directly north, then like the index for that is 2 because it's 0 based. So then we got to skip like, so 2 times 600, so then we kind of like get the offset here. And then in a given, and now it's time for like So now we have to consider like what the other one is, right? So what more? How do we get like the actual entry? So this like gives us the offset for the direction, and then it's time for the rows, right? I know I've done this like several times in like an earlier stream, but like we're in 15 by 20, right? 15 by 20. So then the first row, if you consider row 1, that'll be 0 and 19, right? And that's 20. So this is a 20th one, right? 20 to what? 20 to like almost 40, like 39, right? 39. Like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Exactly, right? So now if we want to like kind of like, let's just say take the 38th, right? The 38th, if the coin is discretized to be at 38, then like if you're flattening this thing from 2D to like a 1D, right? Then how much? Like we have like in the row coordinate is what? Like what is this coordinate, right? The row index, the R index, and the C index, right? The row comma coordinate is 0, 1, is 1. And then what's the column coordinate? It is 0, like it is 18. 18, right? So how do we go from 118 to 38, right? Well, we take the row index and like just like how we kind of skipped past like the 300, like which direction, you have to multiply that by the number of rows. I mean, so sorry, the num calls. What am I talking about? 20, right? So like 38 is 1 times 20 plus 18, right? The number of columns, the row size, which is the number of columns, right? So that is the row index. So that is a coin quarts of 0, the row index times the number of columns. Wait, did I not do it correctly? No, I did. Number of columns, like that. Times the number of columns plus, and then that thing times 1, right? And then plus the just like that. Policy data index. So is this correct? Is this correct? So then this is the row index. Oh wait, no, it's 1. What am I doing? Okay, so that's the row index, and that is the column index. So that is R in my picture right here, 1, and then C is 18. So that's 18, and then this one is 1 times the number of columns is 20. So that's 20. So that's 38. Okay, yeah, perfect. So I think that should be correct, right? That should be correct. Okay, I'll put a to do verify this. Okay, so let's just pretend that, I mean, well, I'm pretty sure it's at least in the correct vein of like, this is stuff we've been doing lots already. So okay, so let's just say that this is correct and move on. I will verify this off stream or think about it some more, and like, well, I mean, it's 2 o'clock now. I'm kind of hungry. Okay, let's just like get past this and like treat this this thing as a stub, and then like do some more cleanup later. So anyways, so okay, so now we kind of like looked at, like we kind of like say, like, let's say player 1's turn, right? Then we get all of player, we filter out, we get all of player 1's coins, and then we like kind of discretize the coordinates, and because like the encoding and like the inputs and output discretization kind of matches, right? I already talked about this. We get the coordinates, and then from And then for each move, what we do is like we kind of build the move. We assume that like we have a helper function that does a trig math.sine and cosine for us. And then like so like we kind of like get the actual velocity components, and then we kind of return from the coin, the move dir, we are able to generate an actual move. And then we kind of like get its probability. And we're also keeping track of the sum because we want to normalize this, right? So now let's do the normalization. So basically like this whole thing right here, like these two nested for loops, what they're essentially equivalent of is legal moves, is like game state.get legal moves in a sense, right? So then now what we can do, we can just kind of copy these lines, right? Because like this is agnostic to like bump connect for logic. This is the sum is not equal to 0. We just like renormalize by dividing everything by that. And if it is 0, then what we do is we just kind of set everything to uniform, right? Just like that. Okay, that looks good. Get status, declare, get diff. We just kind of like did some, okay. Any more changes? Nope, that's all. Declare, get status, get add. Oh no, before adding, let's make sure it compiles. Nope, there are some errors. I have to import policy. Let's just do that. And move. Status, declare, TSC. Moved error. Okay, fine. V net.ts, line 99. Move dir is less than that. Move dir. Just see move again. What do I call it? Move like move dir. Oh, I call it move ID. Oops. Okay, let's just actually fix that quickly, or let's just make that change. Let move. Or actually wait, no. Percentage S, I think, in the Vim. Let's do GC to global and confirm. Move dir should become, move dir should become a lowercase. I don't want num move dir, but thankfully that uppercase kind of breaks the match to move ID. And then GC. Move dir to move ID, yes, replace. Move dir, yes, replace. Move dir to move ID, yes. Accept that change, substitution. Get policy from that, from move dir, yep, move ID. And move ID, and then move ID, and then move ID, and then move ID. And that's it. Okay, good. Okay, so one error is legal moves, and let's look at what's going on. Check that out. 117. What's happening here? Legal moves with probs, right? And again, this cannot be 0 because like legal moves with probs, we're kind of generating based on the coin. Like if we have a single coin, we at least have 8. We at least have like num move dirs, right? And we know we have to have a coin because there is a king coin and the game's not over. My batteries, how much is left? Okay, I should end soon. Let me just make sure that compiles now. Clear. Okay. Status. Get add all. Clear. Get diff staged. So let's copy get policy and value from my git commit message. So I can save the work I've done so far. Git status, git commit, some untested work on net dot get policy and value. get status. Okay, and I'll push later off stream. Okay, so that is all for now, I guess. I will look over this, but yeah, overall it looks like it looks like we're on the right track. Like right now, like back to the overall idea, like net input, and then we created the neural net, and then what we're doing is we're like the net spits out a number which is like 2400, right? Yeah, 8 times 15 times 20 is 2400. We're 8 move directions, 15 row height. I mean, yeah, height, and then 20 width. So that's like 2400 vector of 2400 entries. And from that vector, based on the coin's positions, we're able to, like, in theory, extract a policy. Like, hopefully, in theory, I did it correctly. I mean, I think so, but that's the idea. We extract a policy. So yeah, if I'm right, then we're basically done with everything for self-play. And all that's left now is for training. And then, yeah, symmetries too. Like, symmetries are part of the data augmentation for training. But yeah, I think that's all for now. It's a good stopping point. So yeah, later.